might not have time to actually do code for this, but we can at least do this conceptually. This is another question that was posted for tonight. This is, in most ways, a two-part question. So let's take these two parts somewhat separately. And I've essentially copied this from what they shared with me. So presumably this is what you might see in real life too. So part one is find whether a string is divisible by another string. And you might ask, well, what does divisible mean? Well, the next sentence goes on to say a string is divisible by another string if that other string can be concatenated, can be duplicated some number of times to obtain the larger string. So for example, if our string S equals something like this, and our string T is simply ABCD, then we can say that S is divisible by T. Because as you can see, if we duplicated T a single time, we would get S. Similarly, this would also be divisible. Multiplying T by 3 will get us to S. So these are just two examples of strings that are divisible by another one. Let me update this to give you another example that isn't divisible. And now that I've updated it, S is no longer divisible by T because there's no number of multiplications. There's no number of times that we can duplicate T to equal S. So that's part one of this problem. Part two says if S is divisible, so if it's divisible, find the smallest such string that can be concatenated some number of times to obtain both S and T. So let me go back here. Let's change this a little bit more. Let's add some more ABCDs on here. So what this second part is saying is of this string T, what is a substring that, if multiplied, would give us both T and S, or T or S if multiplied the appropriate number of times. So in this particular case, the substring is this right here, ABCD. ABCD times 2 is T, and ABCD times 4 is S. Part 3 says if it is not divisible, just return -1 from our function. If it is divisible, return the length of the string U. So in this case, that has length 4. So once again, I think this is an interesting question because either one of these questions could have been asked by itself. Part 1 or part 2 could have been a question in and of itself, but someone decided I'm going to make this extra challenging and put both of them together into a single problem. Any questions about this problem statement?
Is number 2 something like GCD in math? Greatest common divisor?
Is it like greatest common divisor in what?
I mean, the second one, U would be GCD for both strings, right?
Yeah, that's probably a good way of thinking about it. Because T, as we've already decided in part 1, is a divisor of S, then we know that U, like we can essentially, for step 2, we can essentially ignore the S string. Because we know S is a multiple of T. The only question is whether is there something within T that can be a multiple as well. Any other questions about this problem? Okay, so we just have 10 minutes left. So I don't think I'm going to focus as much on, I'm not going to get to the code part as much, but maybe we can talk about this conceptually a little bit. And first, let's focus on step 1, or part 1. Is anyone here, let's make this interactive. Does anyone here have any thoughts on how we might do part 1 of this? What would be a simple and or efficient way of doing this? Any first thoughts that people want to share?
Well, one approach is that the length of S should be multiple of length T before doing it. If it's
Absolutely.
not, we shouldn't bother at all.
Let's write up a little basic function prototype here. Car S. So let's say we're passing in the pointer to S and a pointer to T and the length of each as well. You could potentially say that, oh, it's going to be null terminated, but well, the problem statement didn't said we had to write a function, so I'm going to write a function prototype however it is that I want to write a function prototype. So we could absolutely start off by saying essentially is S length mod T length equal to 0. And well, maybe you might say if not, but whatever it is, we can potentially exit out of part 1 very quickly if it's not a multiple in terms of the length of the other one. All right, so what next would we do? Let's say that the length is some multiple. The length of the smaller string is a multiple, divides evenly into the length of the larger string. What would we do next?
I guess can you hear me?
Yep, I can hear you.
Yeah, I guess the first thing that we need to figure out is what is the repeating string in string T, which is the divisor, right? So,
well, so it's worth pointing out. So this is potentially a two-part problem, part 1 and part 2. It might be possible. It might be most efficient to write a single solution that does both. If I was given this in an interview, my first thought would be, okay, let me solve these two problems separately, and then maybe I can think about how I might be able to combine them into a single solution. My concern about trying to combine these into a single solution from the get-go is that it may or may not be impossible, but it might be difficult. So in general, in the interview, it's not that you want to do the stupid thing first, but it's oftentimes best to iterate, like, okay, I'm going to come up with kind of my first thought of what the solution should be, and maybe sketch it out, maybe even write the code. And then the interviewer, if they care, might be like, oh, can that be improved upon? Or you can say like, oh, actually, I can see it can be optimized in this particular way, and you can make it better. So in this case, I would shy away from trying to solve everything at once. Let's just focus on step 1, because if S is not divisible by T, then we can just return -1 and don't have to get to step 2.
So I will make a loop. So if we said if in first step we check, and then we see what is how many times T is in S, and then the loop by this number of time. And in the loop, I would do memory compare between S and T. And in each pass through the loop, I will increase S by size of T, and then do repeat memory compare.
I think that sounds
so
great.
If memory compare fails, then it's, yeah. Mm-hmm.
Oh, yes, sorry, I think that is great. So just kind of say that another way, conceptually what we're going to end up doing, and correct me if I got this wrong from you, is on the first step, we're going to check, do these two match? Second step, do these two match? These ones match, so on down the line until we get to the end of T. And if those ones have all matched, then we're going to loop back to the beginning of T and continue moving on S. Logically, I think that's what you were describing.
Yes, illogically. Except yeah. I would just use memory compare, which can compare like longer sequences of bytes rather than one by one.
So you're saying let's compare all of these bytes using one mem compare with all of those bytes on the first round, let's say, and then compare all of these on the second round.
Yes. Also, and then we would just update S, advance pointer in S to this second part. Yeah,
absolutely. This is a fairly simple approach. And if we're doing it character by character, we can see that it's effectively O of N, N of the longer string. It's worth pointing out that mem compare is often implemented, not that it could potentially be optimized in some way, but is oftentimes implemented internally as just a for loop going byte by byte over the contents of whatever it is that you're doing. So memcompare may or may not be faster than doing it yourself byte by byte. It actually, implementing memcompare actually is an interesting interview assignment in and of itself. And I've seen people say implement memcompare because the trivial way of implementing memcompare is byte by byte. But if you say, oh, if I'm trying to compare two things that are 4 bytes each, I can take advantage of the fact that my architecture can compare a 4-byte word to another 4-byte word and do that in one operation rather than 4 operations. But what if I'm given 5 bytes to compare? Well, I can do one 4-byte comparison and then one 1-byte comparison. But
yes, and I think the reason I would use memcompare, usually I would go by assumption that it's optimized.
Yep. Oh, absolutely. I'm just going into some of these details because I think they're interesting and because you may actually have to implement it yourself someday. And the one final thing with memcompare is that, yes, you can compare 4 bytes at a time, or maybe even 8 bytes at a time between two regions in memory. But generally speaking, your architecture requires that the memory be aligned. Like if you're gonna read 4 bytes of memory, it needs to be on a 4-byte alignment. Like if you take the address and divide it by 4, there better not be a remainder. So the implementation of memcompare ends up being potentially very complicated to support all of these potential cases, which is why sometimes in this particular case, I agree, using memcompare is faster. Almost certainly faster. But there are some cases where memcompare might be slower because it has all these if-elses in there. And if you know, based on the contents of whatever it is that you're doing, that is always going to have a particular characteristic in terms of the memory, it might be faster for you to essentially implement like a little mini memcompare that's specific to what you're doing. And it might ultimately be faster than using the official memcompare. Once again, in this particular case, official memcompare is probably faster. But I want to point out that because it's doing a lot of things that are, in theory, optimizations, but if they don't come to pass, then all they're doing is unnecessary checks. It might be faster to avoid. Okay, so that was step 1. Mostly straightforward. I think the average person would be able to like jump right on that and see that as a reasonable solution, and see that as probably the optimal solution. Using memcompare in particular, that is. Step 2 is the one that's a little bit trickier. I think folks can probably see like a naive solution might be some sort of double or triple nested for loop that iterates through things multiple times to try and figure out whether or not something is a multiple of something else. But does anyone have any thoughts on, maybe before I get to that slide, on how we might do this? And maybe taking a step back, when it comes to a lot of these sorts of like string processing or process this array of bytes, whatever it happens to be, not always, but oftentimes the case that you're trying to search for is, can I do it in O of n? In other words, can I essentially process each character in the string a fixed number of times? Can I avoid having multiple loops? It's not always possible, but that's kind of the best case scenario oftentimes. So anyways, back to my question. Any thoughts on how we might go about this?
I can do a binary search where I can split it into half, check compare, then split it into 1/4, compare the first 1/4, the third and fourth character, something like that.
That could potentially work well if we were dealing with multiples of 2. So if, for example, in this example here, I have the T essentially has 2 copies of it in there. But what if T was like this? If you split it in half, you're not going to get 2 things that match, and splitting it in half again isn't necessarily going to help you.
Yeah, makes sense.
So I like the way you're thinking, because oftentimes this sort of divide and conquer sort of solution is helpful. In this particular case, because of how the problem is described, you would need to divide it in half or thirds or fifths, or really every other, at least prime number going on forward from there. Okay, so because
if we use, how about if we use a frequency counter?
trying to figure, so essentially see if each character in the string comes up the same number of times?
Yes. If it
And
comes
so let's,
number of times, then basically whatever has that number is part of that string, right?
what if I had this?
Yeah. I think the problem is that we do not keep track of the order of the characters. Yep.
Yeah. So not to say that there might be a solution where it could be optimized by doing that first. There are scenarios where you might do an unnecessary step because it allows you to avoid a more expensive step later. But let me kind of cut to the chase of a potential solution for this that can be done in linear time. So first, let me describe it to you. And it's also identified, we only need to look at the shorter of the two strings because we already decided the short string was divisible or could be divided into the longer string. So it's not any good need for us to look at the longer string. And I have here ABC, ABC. So let's assume, well, at least for the first one, let's assume that that's kind of our numbers. What we're going to do is maintain 2 pointers or 2 indices. And those indices are going to start pointing at these 2. Let me use something more descriptive. Let us say we have pointer X and pointer Y. They're going to start off pointing there. We're going to check, do the characters that those point at, do they match? In this case, does A and B match? They don't. A and B don't match. What we're going to then do is increment Y. We're going to move Y. Oops. There we go, eraser. We're going to move Y to here. Okay. Oh, and then we're going to store. We're going to keep this table up here to kind of keep track of what it is that's matched and what hasn't matched so far. And then once this table is filled in, we can make use of it to figure out whether or not there was a duplicate. Okay. So in this case, we're going to compare A and C. A and C don't match. Okay, so we're going to put 0 there, and we're going to move Y over here. Now we're going to compare X and Y, or those pointers, and look, they match. They both point to A. Fantastic. We're going to store 1 here. I'll go into what that 1 means in a second. And now what we're going to do is we're going to increment both X and Y. We're going to move X up to there, and Y up to there. Move them, shift them both up by 1. And now we're going to check, okay, do they both match? And in this case, they do match. So we're going to keep track of essentially how many times have they matched in a row. They matched once last time. Now they're matching twice this time. So we're going to store 2 in this array. And then we're going to do the same thing again. We're going to shift X and Y over by 1. We're going to see they both match with C. And we're going to store 3 in this final entry in this table. So once we've entered everything in this table, now we have to ask the question. Well, now what we do is we look at whatever the final entry in this table is that an even divisor of the entire string length? In other words, is 6 mod 3 equals 0? If yes, then perfect. We have discovered that 3 is the number that we were looking for. 3 is the number of consecutive characters that is duplicated in this string. And you can see with this heuristic, this algorithm I just ran through, we never went in circles. There was never a loop in that kind of sense. We were always looping through the characters in this string a single time, checking them essentially one by one. We were checking each one twice in a sense, but 2 times the number of string is still O of n. I'm not going to go through the other 2 examples I have here, but if we follow the same algorithm, which is if they match, we store a counter, and we store in each entry in that table how many times have they matched so far. And if they don't match, we either put a 0 if they've never matched before, or let's take the case of the second. It's already 8:05. Okay. If they don't match, then we're going to store one below the last time they matched. So if, for example, this last one wasn't a C, it actually was a D, then what we would do is rather than storing 3 here, is we would store 1 here. That becomes more pertinent if it doesn't match someplace in the middle. We can potentially talk about this more next Tuesday if people are actually interested in more of the C code and more of these examples. But I also don't want to take up people's time now since we're already over. But hopefully people understand that this is kind of a general algorithm that can progress through these in O of n time. And if we combine the first algorithm we talked about here to check whether or not one is divisible by the other one, if it is divisible, then we move on to this algorithm, which only requires a small array for bookkeeping, or an array of equal size to the strings for bookkeeping. And there's 2 pointers that we use to move along our array. We can then conclude either is there a multiple and what that multiple number is to return it, or if not, return -1 or whatever the appropriate value is. Once again, don't want to go into too much more detail at the moment. Definitely post for next Tuesday if you want to learn more about this. Or if there's anything else we went over today you would like to go more into, or other variants of the question, feel free to pose it for next Tuesday. But any easy questions that we can answer right now in terms of confusion of this problem before we get going tonight?
Glenn, one question. Is this some standard algorithm?
Is this a standard algorithm?
I mean, is this something that is out there, or it's something that you came up with? That's my question. Sorry.
This isn't, how to best put this. When I first sat down to do this, I came up with a slight variant of this. And then when I looked online to kind of be like, hey, like, is there a better, for a lot of these things, I like to sit down and do it myself first and then look online. It's like, is there a better way I can explain this than the way I happen to do it? Then I found this variant. So what I described to you was kind of the slightly more optimized way I found online, but you always could come up with this on your own as well. But it is a general kind of algorithm pattern, the pattern of trying to avoid checking something that you already checked. And with this kind of set aside table that we're going to use as a scratch space, that's something that's going to come up a lot more this coming Sunday. There's a lot of other algorithms, heuristics, approaches to solve a problem where the trade-off is between memory and processing space. But this obviously is going to cost us more memory to store this data, but we're saving some processing time and making it O of n. We could have come up with some other algorithm that would be slower, that doesn't require as much scratch data, but there's a trade-off to be had there.
Glenn, when you change it to D, when you compare C and D, why the count you make as a 1, though it doesn't match? Should be 0, right, if it doesn't match?
Yeah, so this is, I'm thinking, I kind of sped through this a little bit. If they don't match, we're going to change the value to the last stored table value, unless the last stored table value was 0, in which case we set it to 0. So if we never had a match before, we're going to set it to 0. But if we did have some matches just an iteration or 2 ago, then we're just going to decrement it.
We should say 2 or 1, because the last stored value was 2, right? I think it matched until.
Yes. Sorry. Let me take a quick look here. Yes. Sorry, you're absolutely right. So I did that. This is what I get when I start speeding through things at the end. That value should be 2.
And also, like an example of sorry. Yeah. I just wanted to get a quick example of AB. If there are 3 ABs, what number will you put for the third AB?
You know what? Let's actually take this as a topic for next
Sure.
Tuesday. There's a couple other examples we could go through here, and yeah, I don't want to shortchange it by being quick and confusing, as I think I'm already starting to be.
Sure, no problem. Yeah, we can do it next week. Thank you.
Yeah, but definitely, once again, next week and this week, in terms of the Tuesday and the Thursday sessions, I kind of look as being an extension of each other. So we're going to obviously cover more topics this upcoming Sunday. but I'm happy. Everything in these 2 weeks definitely feed on each other. So everything we did Sunday and tonight can definitely come up as another topic next Tuesday. So feel free to take advantage of that. And similarly, if you posted a question that either I didn't get to or maybe I didn't get to adequately in your mind, definitely feel free to post it again, and we can dig into it further. So with that, thank you so much for sticking with me a couple minutes over. As I'm very much about being punctual, and I realize everyone's time is important, and I don't want to waste anyone's time unnecessarily or try and rush things and do a bad job. So hopefully we have plenty more time next week to cover these things. But thank you so much for sticking with me today.